Hi, my name is Thomas Hill. Today I prepared a brief video outlining my project for the MBA 624 Project Management course. I've chosen a project which is theoretical and only in concept stage, but has potential to be applied in the real world, specifically to my field, which is aerospace component manufacturing. The project is the application of RFID technology to the manufacturing shop floor to help control and monitor work-in-process inventory with the goal of reducing costs, reducing lead time, and improving on-time delivery and quality to the customer. This video will outline the details of the technology, how it can be applied, and how, if implemented, this project would benefit an organization. RFID stands for Radio Frequency Identification, which by definition is the wireless non-contact use of radio frequency electromagnetic fields to transfer data for the purposes of automatically identifying and tracking tags attached to objects. Let's watch a video from Core RFID explaining how RFID in manufacturing can work.
You know that in your business, information is power. Being able to track your assets effectively, reducing the time you hold on to stock, and monitoring the flow of work in progress can save capital and improve delivered quality. But sometimes capturing the right information at the right time is expensive. It can take too long to get the data you need, and it can be difficult to make use of it when it counts. That's where RFID technology can help you. These are RFID tags. They come in many shapes and sizes, but they all do the same job. They tell you what things are. Readers, like these, interact with the tags to collect information, like where things are. So you can track individual components on the assembly line, individual steps in the production process, testing and quality control, completed goods, pallets of products, and even items sold and later returned under warranty. With these tags you can capture data where and when it happens and use that data immediately. To help you do this easily, we've developed our Flow OK software solution. Flow OK automates the collection of data at every step of the process. Use it to monitor the whole end-to-end production process. Use it to tell what stage in the assembly a product has reached. Use it to tell you how many products have been completed. Or use it with gateways to tell you when goods move from one place to another. Flow OK delivers information across a simple web interface and integrates with industry standard hardware and ERP software, as well as with your own in-house systems.
RFID technology is really useful for tracking a product through its entire life cycle, not just at the original manufacturer. OEMs such as Boeing and Airbus have really put forth a strategy where they want their suppliers to engage in using RFID technology so that they can track through all the way to the end customers and then back through MRO facilities when necessary. Implementing RFID technology in a manufacturing environment requires a lot of design and forethought. It is helpful to include experts and consultants from the vendors that are implementing the technology to make sure that the deployment goes successfully. In the next video, we'll look at an example case study prepared by the RFID network of an application in an aerospace environment.
Chances are you've never been to an aerospace and defense manufacturing facility. These are extremely high-tech facilities that design and produce sophisticated electronic components used in a variety of military and commercial systems.
Hi, I'm Lou Sirico, and in this special edition of the RFID Network, we've been given a rare opportunity to go inside a high-security facility for a look at how RFID technology is used in the manufacture of unmanned aerial vehicles and guided missiles. In this edition, we're going to take a look at how RFID technology is used in the manufacture of aerospace and defense equipment. And I'm with David Hall, General Manager of Microsemi's RF Integrated Solutions Division. David, welcome to the RFID Network.
Good morning, Lou. Thank you. It's nice to be here.
So David, tell us a little bit about the RFID solution that you've implemented.
Well, Microsemi, not unlike most major manufacturers of electronic companies, is always looking for ways to manufacture products more efficiently and to be able to collaborate better with our customers. The RFID solution that we've implemented from Omnitrol, first and foremost, provides us with a level of collaboration, both on the shop floor with the people who have to build the product, as well as with our customer.
So what does collaboration have to do with RFID technology?
Well, RFID technology gives me knowledge, and with knowledge comes power. And that knowledge enables me to know exactly where my product is on the shop floor at every moment of every day. And at the same time, I can communicate that same information to my customers.
What are some of the business benefits that you've achieved?
There are a number of business benefits, but not the least of which is on-time delivery. I understand where my product is. I can let my customer know when they can expect it, and they can plan accordingly. And that's critical for them, being able to understand where I have problems, understanding technically where I might be able to make improvements. And that's important as I run the shop.
Now that we've seen some examples of how RFID technology can be used in aerospace manufacturing, I'd like to go over some of the highlights of the project plan that I've laid out for the hypothetical implementation of this technology at my facility, which is an aerospace manufacturing site. The objectives for the project plan are to provide real-time visibility with a virtual interface to the inventory on the shop floor. We'd like to increase the inventory accuracy by 20%, reduce the time that's involved from planners and team leaders and customer service tracing units and work orders, provide immediate status availability for the customer service group, saving time from walking to the shop floor and increasing customer satisfaction, reducing the average work order age by 20%, and increasing our customer on-time delivery by 10%. This project will require a fully cross-functional team composed of plant leadership, supply chain, materials management, operations, finance, manufacturing engineering, customer service, and IT to make sure that any of our company systems will integrate with the vendor systems for the RFID software. There will be an element of change management involved with this team, as this is a new technology and it is kind of overriding a long history of manual processes. So this team will have to put together a strategy for communicating the project and communicating the change and making sure that it impacts all the groups as designed. The project duration will be at least 18 to 24 months. The biggest part of this is the initial phase, which is proposal collection and CAR approval. That's the capital appropriation request. At our organization, it takes a long time to get funding approved for infrastructure that would be required for this. The software and the hardware would be pretty expensive. So it would take at least 12 months, we believe, for the proposals to come through, the review with the vendors to come through, and then a project CAR to be approved to get the project going. After the first 12 months, we would expect another 3 months for design with the vendor of choice. After design, we would have at least a month of infrastructure installation for the pilot rollout. After that, we would have testing and user acceptance testing for 2 months, and then final modifications and final implementation for another 4 months With another 3 to 6 months of maturity, this project could take at least 2 years to roll out just in the pilot stage, and then after that, you'd have to follow similar approaches to roll it out to the rest of the facility.